Hi, I'm Trisha, and this is my poster. The Bronsted-Lowry definition of acids and bases. An acid is any substance that can donate H plus ions, and bases are any substance that can accept H plus ions. So one gives and the other one takes. Okay, so here are some acids and bases. Most acids start with H, except for if they are an organic acid, then they might start with something else but have H in them. So, for example, hydrochloric acid, nitric acid, phosphoric acid, sulfuric acid, and acetic acid. Acetic acid is an example of an organic acid, so it starts with a C but has an H in it. Some examples of some bases are ammonia, potassium hydroxide, sodium bicarbonate, sodium carbonate, and sodium hydroxide. Most bases have OH in them except for one like ammonia, but ammonia reacts with water, causing it to be a base.
I'm
Go.
Bailey, and these are the properties of bases. It tastes bitter, like getting soap in your mouth, if you've ever had that happen. It's smooth and slippery, like a soapy bath. It does not react with metals at all. It conducts well for electricity. Mostly, it depends on what kind of base it is. And it turns litmus paper from red to blue, unlike an acid, which turns it from blue to red. And that's all.
Presenting on acid properties. That's what I'm presenting on. So the taste, it can either taste sour or tart. The sour ones you get from like oranges and like grapefruits. That's called citric acid. The tart you get from like sour milk and yogurt. That's called lactic acid. And carbonated beverages have carbonic acid in them. And also vinegar has acetic acid in it. Switch up. What's the next one? Touch. Diluted like solutions, they like feel like water, so it's like normal. But like if it touches your like skin where there's like a cut or something, that's gonna sting and not feel very good. They react quite vigorously with metal. Like, have you ever seen that? It's like, anyways, and indicators. There we go. With litmus paper, I'm sure y'all know what that is. Like, it turns the litmus paper from blue to red, and it's purple in the middle, and it's magical. And then it is a good electrical conductor. That has been Acid Properties with Anna and Bear.
Go.
We are Christina and Bailey, Joe Novi, and Larson. These are conjugate acids and bases.
When an acid loses an H ion, it becomes its conjugate base.
And when a base gains an H ion, it becomes its conjugate acid. So an example of that is NH3 plus H2O. This is a base and this is an acid, and that becomes
NH4 plus OH conjugate base. AG. Yeah. Cool.
So water is an acid?
Good.
I'm Christina Novi, and I did my poster on strong and weak acids. Some examples of strong acids are hydrochloric acids, sulfuric acids, perchloric acids, nitric acids, and hydrolodic acids. Some examples of weak acids are acetic acid, hydroaconic acid, nitrous acid, hydrofluoric acid, hypochlorous acid, and hydrogen carbonate ions. And how does that affect their conjugate acid-base pairs? And the answer is the stronger the acid, the weaker its conjugate base.
Alright, so for neutralization, we have our reaction. You have your acids combining with the base. That gives you your reaction, and that will give you a solution. So some examples here are carbonic acid. That's an acid. You add calcium hydroxide, which is your base, and that'll give you calcium carbonate. That's your solution. Another example, hydrogen chloride. plus sodium hydroxide, and that'll give you water and salt. Now for our Arrhenius bases and acids, which is a definition. The definition for an acid would be a substance that, when dissolved in water, increases the concentration of hydrogen ion H+. The Arrhenius base definition of a base would be a substance that, when added to water, increases the concentration of hydroxide ion OH negative.